Hello everyone. In this session, we'll use MoodFrame, a multi-agent application, to explore how an app built locally can be deployed step by step to Azure. We'll begin with the application architecture, follow the containerized deployment path, and then extend the discussion to identity, security, and operational monitoring, so it becomes clear that it runs and it is ready for reliable production use are not quite the same thing. MoodFrame uses a separated front-end and back-end design. The browser lets the user choose an emoji, the front-end SPA handles the interaction, and the fast API back-end coordinates the overall flow. Rather than placing every capability inside one service, the back-end calls two independently deployed agents through A2A, which keeps each responsibility much clearer. The two agents each have a focused role. The MoodFrame content generates the caption and hashtags, while MoodFrame image generates the structured visual description. Both use the GitHub Copilot SDK and call GPT 5.6 Sol, so you can think of them as two specialist colleagues working behind the back-end orchestration layer. The deployment path begins with Azure Container Apps, which is well suited to getting the services running quickly and checking the end-to-end flow. It then moves to AKS, where we gain fuller Kubernetes control. The four container images are stored together in Azure Container Registry, which acts rather like a cloud delivery shelf that each runtime environment can pull from when needed. This deployment overview lays out the full MoodFrame path, from a user clicking an emoji through to the services running in Azure. The browser loads an SPA built with HTML5, CSS3, and JavaScript. Nginx then acts as a reverse proxy, forwarding API * requests to MoodFrame API. The fast API backend sits in the orchestration role. It validates JSON, calls Pillow to produce a downloadable PNG, and coordinates the multi-agent workflow through two A2A calls. The content agent produces the caption and hashtags, while the image agent produces a structured scene description. Both use the GitHub Copilot SDK with GPT 5.6 Sol. At the deployment layer, all four images are pushed to Azure Container Registry. ACA exposes web through an external endpoint while keeping the API and agents internal. AKS uses load balancer and cluster IP to separate access boundaries. Entra ID, Defender, and log analytics are included to make the point that cloud-native deployment is not simply about lighting up containers. We also need login, protection, and visibility once the system is running. This page gives us the directory map for the MoodFrame project, bringing the cloud components back to their actual implementation locations. The agents directory contains the two MAFA2A agents. Backend holds the fast API orchestration and PNG rendering work, while frontend maps to the web SPA. The infra area is split into ACA, AKS, and security, supporting Azure Container Apps, AKS, and the related Entra ID and Defender configuration. Code is the main workspace for application source and deployment assets, and Labs breaks the practical exercise into step-by-step tasks. For cloud-native deployment, understanding this map is important before running commands. Otherwise, it is very easy to feel as if you are hunting for door numbers in the dark. Once each folder's job is clear, image builds, service deployment, security configuration, and lab steps connect much more smoothly. The structure of this session can be summarized as for application components and two deployment environments, web, API, content agent, and image agent make up MoodFrame, and we then examine how it runs cloud natively in both ACA and AKS. After the session, consider why web is suitable for external access, while the API and agents are better kept internal. Also think about how Entra ID, Defender, and log analytics protect the workload from the perspectives of identity, security, and operational visibility.